All right, good afternoon, grade 11s. I received a request this morning on a video that I made yesterday surrounding trigonometry graphs, and the request was to please have a look at tan specifically. So I just need to add, it took me about 20 minutes to get one or two examples to do with you guys. So in general, tan is not one I had to search far and wide. I actually went through, I think, about 2013 matric end exam up to about 2016, 17, and I could only find one example with a tan. Plus the examples that you find is really straightforward. You would see it now when I do it as well here. This first example I got from my X Factor book, and it's pretty straightforward. So bear with me. Let's have a look, listen up. I hope I answered the questions that you have surrounding tan. So the problem that you have with tan is the fact that tan is the bad boy of trig graphs. Bad boy meaning he doesn't really do what the other graphs do. If you think in terms of grade 10 and sin and cos, it had a period of 360, tan had 180. They had amplitudes, tan had nothing. Their form was pretty much the same, tan was totally different. So he was always against the stream. So like I said yesterday, when you receive a question in terms of finding the equations of trig graphs, you would always be guided towards what the answer is that they want. So this sketch has the following with it. It says the f of x is equal to a the tan of x. So immediately I know what? I know that what is expected of me in terms of this graph. This graph did not move up or down. Why not? Because there's no plus q. This graph did not move left or right because there is no minus p. This graph's period did not change. Why not? Because there's no k value. The only thing that happened to this graph, the only change that it undergone is there by the a because it's indicated. And that, remember, with tan is not an amplitude, but that is to do with the curve of the legs of the graph, as well as my reflection over the x-axis. So therefore, boys and girls, that's the only thing where you're going to take your, and go and put your knowledge to work, and it's going to be on the A. So like I said the previous round, in the previous video, important to me is we need to know the standards of grade 10, the standard form, the standard graph. I just showed you, by knowing the standard form, I know what's happening in terms of the tan graph. Now I'm going to show you in terms of the sketch. Now there's very little in terms of a tan sketch that is standard things you knew. And the two things that stood out to me is asymptotes. Another thing that stood out was that 45 degrees equals 1. So in your standard tan graph, it's going to look like this. I'm going to have a curve. It's going to just be a little bit lower than that one, and it's going to run this direction. It's going to be a little bit higher. Why? Because in my standard form, over 45 degrees, so here when I get to 45, over here, the value is 1. And that will happen every 135 degrees. So, not 135, excuse me, 90 degrees. So here by 135, if I do that, you're going to get minus 1. And that is what I know of the standard form. So if I now look at my yellow graph versus my one that was given, and remember you always work from standard to the one that was provided. So yellow was standard, black was provided. What's the difference between the two? Asymptote is still in the same place, there's no problem there. So I'm going to have a look-see, and I see that, alright, the only thing that differs is that 3. Where in standard form it was 1, now it is 3. So ladies and gentlemen, I go back to what I was provided here, and I go and complete my equation. So I say the f of x is equal to 3, the tan of x. Because if it was the standard tan at 45, it would have been 1. Hence, therefore, that would have been 1. And then, ladies and gentlemen, that's 3. When would that 3 be a negative? The 3 would have been a negative f. That graph of mine, that black one, was down at the bottom here. It was reflected over the x-axis, which in this case was not true, so therefore the positive 3. So the job of this tree, very important to remember, the job of this value is to show you what happens in terms of 45 degrees, as well as my reflection. And remember, as soon as we start moving left and right, 45 is now once again going to be a problematic value. You've got to keep that in mind as well. I move to my second example. This came out of a grade 12 question paper. I think it was 2016 or 17. So I'm going to put my focus, once again, there's two graphs on here. I'm going to put my focus only on the tan and what was provided to me. So it said the f of x is equal to tan kx. So what do I know from that standard form? I know that the graph did not move left and right. The graph did not move up and down. There was no change in terms of my A. That means my curve. The only thing was the K, and the K did what? The K either stretched or compressed. So it worked with my period. So have a look here. If I look in terms of what is written in front here, that would have been a 1 because there's nothing there. If I go to my sketch, look at that. There is the 90 and 1 value. Just 1 second. I just want to quickly get this guy centered again. And that's the 45 that I've mentioned previously. Remember, normally the standard one would have been 45 and 1. Now it is 90 and 1. So what I'm going to do is, I'm just going to, on this thing, draw my standard trig graph. So my standard trig graph would have looked something like that. And then there would have been a asymptote at 90 and at minus 90 on this side. And so exactly the same thing happens. We've got very little in terms of standard things to look for at the tan. And I said the only things we can use, or that is there to help us, is the 45 and 1. And remember, on this side is going to be negative 45 and 1. You can use that as well. And minus 1. And then your asymptote. So if you now look at the 2 points, look at the 45-1 and the 91. What happened? 45 became 90. So that meant the graph was stretched. What is the scale factor between 45 and 90? The scale factor is 2. I can also, and this works pretty decent as well every single time, I can also use my asymptotes. Because I know the standard asymptote is 90. The new asymptote is 180. What happened from there? Scale factor 2. So 2 is going to be the leading role player here. So, remember, if I stretch, like Jamil would say, elongate. If I stretch, it's got to be a fraction. If I compress, it's a whole number. So hence, therefore, my final answer here says this. The f, just want to get the right one here. The f of x equals tan half ax. And then remember, what they also like to ask is, what is the new period? So then you can go, and now you know what the k is, so the new period will be 180 divided by half, which is then 360. Grade 11s, that's really the best examples I could get for you guys. Please go and have a look in your X Factor books. Please go and have a look at old question papers. Like I said, this one came out of a grade 12 question paper, and it's the best example that I could get. Tan is really asked in a simple way, if it is asked. They don't go into that too deeply. All right, have a lovely one.